Hello, I want to begin my presentation today by talking about the bus stop that started it all. So in the spring of 2023, I reached out to my city council person. I was living in Tucson, Arizona at the time, and I wrote a letter regarding pedestrian and public safety in my neighborhood. As part of that letter, I included the top image in this slide, because I thought that this bus stop really was ideal and was kind of a rare bus stop in my neighborhood. And so I pointed out in the letter about the shelter here, which had multiple areas of seating, some airflow, and just a really solid place to get shade from. And I also pointed out this tree. I received a reply back saying that his team would look into it, and I never heard anything else other than a week later when I went back to that same bus stop. I found that the tree had been significantly cut down. I would say that the shade capability of the tree had been cut roughly in half, and so I decided to conduct some research. The title of my research is Shade, Urban Heat, and Public Transportation in Tucson, Arizona. My name is Celeste Maybell. I am an undergraduate at the University of Utah studying environmental and sustainability studies at the School of Environment, Society, and Sustainability. So I started my research conducting a literature review, and I found that heat is the leading cause of weather-related deaths in the US, and that urban heat islands are disproportionately located in low-income and racial/ethnic minority communities. This is a huge problem because it is predicted that climate change will make the American Southwest much hotter and much drier over the next century. And so it is incredibly important for cities to engage with sustainability initiatives to mitigate the worst effects. Two well-regarded methods to do that includes expanding public transportation and creating green spaces by planting vegetation. And so I did not find very much information about green spaces and public transportation. And I was specifically interested in what public transportation waiting areas, such as bus stops, would look like with green spaces. So this kind of led me to my research question. So I decided to ask, do bus stops in Tucson exhibit disparities in heat and shade based off of neighborhood characteristics? I really wanted to dive into the environmental justice angle with this, and I made a couple of predictions along with it. The first prediction is that neighborhoods dominantly composed of low-income or racial/ethnic minority groups will have less shade and less vegetation at their local bus stops. And the second prediction I made is that public transportation waiting areas, specifically bus stops in Tucson, will utilize infrastructural shade, such as bus shelters, more frequently than green shade, which is trees or any other vegetation. So with this in mind, I began the data collection process. And so I chose my criteria for shade characteristics, which I'll go over soon. And then I decided to just use Tucson's SunTran bus system. They also have like a Sunlink system, which is streetcar in downtown, and then a Sunvan system, which is for their shuttle cars. But I just wanted to use SunTran because it was the most expansive public transportation they had. And then for the routes that I chose to collect data on, I did it based off of directional quadrants. So I went from the epicenter of the bus stops or the bus routes, which is in downtown, and then I went northeast, southeast, southwest, and northwest. I chose 3 in each quadrant with 12 bus stops total, or bus routes total, and that ended up with data being collected on 959 bus stops, which is roughly half of the total population, so I was pretty happy with that. Initially, I was going to ride the buses and take survey data on each bus stop so I could get the most current data, but that was only going to lead to like very surface level data on each bus stop, and I wanted to be more expansive and more in depth. So I decided to switch to Google Street View and take images of each data. That was a little bit of a challenge because I needed to find the most recent Google image, and that could be a little tricky sometimes. And and that could, lead to some problems. Like right here, you can see that this image from 2022 of this bus stop, there is a tree and lots of vegetation. But when I crossed the street, I was able to find a more recent image from 2024, and the tree was gone and all the vegetation had been removed. And so, yeah, I did my best to select the most recent image of every bus stop. With that, I also gathered land surface temperature and census data, and then going to be putting them together into GIS to make maps and conduct analysis. So with that, I am going to go over some of the shade characteristics and the criteria I chose, and some preliminary results from that. So the first shade characteristic I looked at was whether or not a shelter was available, and then I needed to break down what kind of shelter was available. So this is an image of no shelter. These are shelters that we categorized as metal, and then this is like a large breezeway or canopy style shelter. There was another shelter which we called cactus style, and that's because of this little branch right here looking like a cactus, and we wanted to collect like separate data on those because cactus style shelters, you can kind of see in the shadow right here, they're semi-translucent, so they let sunlight through still, so it's better than no shade, but they do let sunlight through. And then also these are the preferred bus stops by the city because they're a little bit cheaper to implement. They have advertising signs. However, they are a little bit easier to damage. And so we also collected data on the damage of any shelters that were damaged. So some descriptive statistics from this, I found that 46.7% of the sample bus stops had undamaged city-provided shade, and 50.8% are what I call sun-exposed, which is no city-provided shade, but they might have different ways of getting shade, which I'll go over right now. So this is what I meant by sun exposed, but there are different ways to get shade. So we call this constructed shade, where there's just infrastructure in the city that allows for shade. And so we have canyons, which are these buildings providing shade. We have large signs, which provide shade, the advertising sign. We have big breezeways. There's a bus stop in here. We also have walls or fences that people will use to find shade. And then we have something we called engineering shade or engineered shade, which is just very temporary forms of shade. So this one's like an advertising sale that the bus stop's like right behind here. And then this is like a privately made or like a community made bus stop I thought was very charming. But those are the different forms of constructed shade. So here I found that 27.4% of the bus stops had constructed shade. That did not include city-like shelters. And when we took away the walls, the fences, and the large signs, basically 8% of the bus stops had constructed shade, and that did include bus stops that also had shelters. Next, I looked at ground coverage, so whether it was dirt, sand, gravel, little rocks, concrete, asphalt, or rockscaping. And then this is where vegetation first makes its appearance because I looked at non-irrigated grass versus irrigated grass. So with ground coverage, the descriptive statistics we found was that 49.7% of bus stops had extra asphalt. So I say extra because every bus stop is located next to the road. But if there was more asphalt, such as like this parking lot in this image here, where that bus stop is just kind of surrounded by asphalt, that's what we included in as extra asphalt. And then I also found that 44.2% of the bus stops had non-irrigated grass and 4.8% had irrigated grass. Next, I looked at vegetation, so whether there was no vegetation, and then I decided to split vegetation into irrigated versus non-irrigated. And so irrigated bushes or non-irrigated bushes, non-irrigated cactus versus irrigated cactus, and then I looked at trees. And for the trees, I split them into native or non-native trees, and that's because native trees, you can kind of see in the shadow here, they have less shade capability than non-native trees. And non-native trees need more water. Irrigated bushes and cactus need more water. So that was the important element that I was capturing there, is the presence of water creates cooler areas. Non-native trees also create cooler areas. And so that's what I was gathering there. So the descriptive statistics I got for vegetation is that 8.5% of the bus stops had no vegetation at all. That changes to 18% when you only include trees but no other vegetation. So 18% of bus stops had only trees as their vegetation. And then 47.4% of bus stops had exclusively non-irrigated vegetation, and then 34.6% had irrigated and sometimes non-irrigated vegetation. I didn't do exclusively irrigated vegetation because sometimes there was like non-irrigated and there would be a property line and it would be split. So I counted that in the irrigated vegetation. That wraps up my shade characteristics criteria, but I wanted to also look at who rides the bus. So the SunTrans Service Planning and Development Department surveyed riders, and 54.1% of riders self-identified as low-income earners, and 54.52% self-identified as a racial / ethnic minority on a national level. I found this to be really interesting, but I also want to emphasize that the bus is really ridden by everybody. So some quick examples of who rides the bus includes the elderly, the really young, families, friends, students. There's a college student behind here, and people of all physical abilities. So the bus service is really important in every city, not just Tucson. With that, I just want you to take a second to kind of reflect on what bus stop would you rather wait for the bus at? And keep in mind that bus wait times can be anywhere from 15 minutes at the best to an hour and a half if something goes wrong. So for this research, I reached out to the city of Tucson, and I found that they have 3 tiers of their bus stop. Tier 1 includes shelters, benches, tamper-proof trash cans. Tier 2 included vegetation and stormwater infrastructure, as well as increased security. And then Tier 3 included all of the other tiers, amenities, plus a bike share station. And I would argue that if the city were to restructure their tier levels so that shelters, vegetation, and stormwater infrastructure were the highest priority, as well as benches were the highest priority, the ridership experience would significantly improve for their riders. So the final results for this project are ongoing. We're looking at GIS at 500 meters and 100 meters around each bus stop. We've overlaid the land surface temperature. We're using decennial census data as well as American Community Service block group census data. One of the statistics we found from that, we weighted the data by working population that relies on the bus to get to work, and we found that 23% of bus stops utilized by these folks had constructed shade, whereas 28% on average had constructed shade. So the people who use the bus the most to get to work had less constructed shade. However, we're still doing analysis for statistical significance, and we're going to be looking at vegetation and temperature, shelter and temperature, and shade characteristics and neighborhood demographics. With that, I would like to conclude that when it comes to shade in the desert, everything matters. A sustainable future is one that includes public transportation, and a dignified experience is what increases ridership, and that can be done through increasing green spaces in the city. I would like to say thank you to all these folks on this slide and organizations for professional and financial support as I was conducting this project over the last 2 semesters. And I'd also like to say thank you to you, the audience, for engaging with this presentation. If you have any questions, comments, or concerns, please reach out to my university email and I would be happy to help you. And pun intended, like these young gentlemen over here, I hope you all remember to stay cool.